Okay, this is the June 2015 Physics P1F paper. Go through. Question 1. Different parts of the electromagnetic spectrum are useful for different methods of communication. Figure 1 shows a transmitter emitting two electromagnetic waves, J and K. So here's the transmitter there. Wave J is reflected by a layer in the atmosphere called the ionosphere. Wave K, it will also be reflected by the ionosphere. On figure 1, draw the path of wave K to show that it does not reach the receiver. So it does not reach the receiver. So what we need is a ruler. And what we need to do is we need to trace that path. Straight lines, remembering like light, electromagnetic waves travel in straight lines. Show it hitting the ionosphere, and then, as you can see, it is reflecting. It's reflecting off there, okay, at an angle equivalent. Remembering the angle of incidence is equal to the angle of reflection. So that shows quite clearly the two lines that you need to show. One line hitting the atmosphere, the ionosphere, and then one reflecting down. So that would get you 2 marks. What is the name given to a dashed line in figure 1? The dashed line in figure 1. I'm trying to see. The dashed line in figure 1. There is no dashed line in figure 1. But what I can assume that they're talking about is that there should be a dashed line here. Okay, and that dashed line there indicates the normal line. Okay, so again, going back to the mirrors, it's the same as the angle of incidence equals the angle of reflection. Okay, figure 2. Figure 2 shows transmitter sending a signal to satellite orbiting the Earth. What type of electromagnetic wave is used to send a signal to a satellite? Okay, this is one where you just need to know this answer. Gamma we could use, but it is too dangerous, so it's not gamma. Ultraviolet comes through, is part of the sunlight, it must be microwave. What name is given to the process that occurs as wave 1 passes into the ionosphere? Well, if you look here at what's happening, we're getting that bending going on, okay? So that bending of light or bending of electromagnetic waves, so it's an application of your knowledge of light, reflection and refraction. Reflection, it would be bouncing back off in, so it's not that. Diffraction, remember, is when it passes through a gap and we end up with it spreading out after that. It's not that, it must be refraction, which it is. Okay, 1C. 1C. Waves J, K and L are electromagnetic waves. What are 2 properties of all electromagnetic waves? All electromagnetic waves are transverse. Okay, all electromagnetic waves have the same speed in a vacuum. Okay, they don't all have the same frequency. Mechanical waves are ones that actually occur in a medium, and longitudinal waves are the ones such as sound. So those are your 2 answers. Well done, you just got 7 marks. Question 2, figure 3 shows a man using a leaf blower to move some leaves. The leaf blower is powered by an electric motor connected to a battery. Energy transfers take place when the leaf blower is being used. Use the correct answer from the box to complete each sentence. The battery stores, what do you think, guys? The battery stores chemical energy which is transferred into electrical energy. Chemical. The electrical motor transfers electrical energy usefully into... It's not going to turn it to electrical, it must be kinetic yet. Kinetic being the movement energy. The motor wastes energy as something energy and as energy that heats the surroundings. It's going to be sound. Okay, 3 marks. 2B. The total power input in the leaf blower is 750 watts. The useful power output of the leaf blower is 360 watts. Calculate the efficiency. So looking at the formula sheet, you should remember that we have total power, so useful output over total input. Okay, so that's going to be useful output, which is 360, divided by 750 times 100, okay, to get the percentage. So if we check that in there, what we get is